We're going to be looking at two sections today. Both sections deal with trigonometry. So we'll look at first the tangent ratio, and then we'll look at the sine and cosine ratios, and then we'll learn how to use these ratios to solve for unknown values in triangles. So trigonometry, what is trigonometry? Trigonometry means the study of measures, right? Metry in right triangles. Trigon, meaning quadrilateral, polygon with three sides. So we're going to be looking at 6 trigonometric functions, but in this lesson today we're going to focus on just 3. First one we're going to look at is the tangent ratio. The tangent ratio. So the tangent ratio is defined as the ratio of the opposite side over the adjacent side. Opposite side over the adjacent side. So what do I mean when I say opposite and adjacent side? Well, I'm speaking specifically of parts of a triangle. So for instance, if you look right here at this triangle, triangle ABC, I'm going to focus on angle B. And in this triangle, angle B, this is the opposite side of the triangle from angle B. Opposite side of the triangle. And this is the adjacent side of the triangle to angle B. So why isn't this guy the adjacent side, since they're both technically next to angle B? Because this guy happens to be the hypotenuse. So remember that adjacent and opposite are relative terms. So what's adjacent to angle B is not what's adjacent to angle A. So now imagine you're over here, right? And you're angle A. Well, now what's opposite from angle A is now this side. This is now opposite from angle A. So adjacent and opposite are relative terms. So each time I give you an angle, you're going to have to look at the triangle and decide what is opposite from that angle and what is adjacent from that angle in the triangle. So let's find the tangent ratio of each angle in this first example. So start with the angle they give us. We're going to look at what is the tangent of angle A. So I go over to my picture. Here's angle A. Remember that the tangent is the ratio of the opposite side. So there's the opposite side to the adjacent side. Adjacent side. So again, why isn't this guy the adjacent side? Because this guy is the hypotenuse. So the answer for example 1A is 15 over 36. And then we'll want to reduce this. All right, let's take a look at the second problem. Part B, what is the tangent of angle B? Okay, so going back to our triangle, this time focusing on angle B, and then looking for the opposite from angle B, right? So now, this is now the opposite of angle B, and this is now the adjacent side of angle B. So that means that the tangent of angle B is going to be opposite over adjacent, so 36 over 15, and then of course reduce. So what do you do with trigonometry? Because you're probably thinking, this seems really silly. All you do is take two parts of a triangle and write them in a fraction. Well, the way that trigonometry is used is that trigonometry ratios, comparing any two sides or a side in the hypotenuse, they are constants. So that means that you could look them up on a table, or in our case, we'll look them up on a calculator. And because all the triangles with the set angles in them are similar triangles, the ratios of the sides always stay the same. So, for instance, this triangle right here is part of an equilateral triangle, where each side of the equilateral triangle was 2a. And because this was an equilateral triangle, all the angles were 60, right? So we can break this triangle down, and without finding specific measures of the sides, we could notice that the sides would be A, 2a, and then this guy right here, the height, or the length of the altitude is root 3a. And if you didn't know that, you could find it using the Pythagorean theorem with the other two sides. So let's find the tangent of 30 degrees. So remember, it's going to be opposite over hypotenuse. So here's 30 degrees. Go opposite, that's A, over adjacent, that's root 3 times A, and then we'll simplify this. 1 over root 3. Okay, and then we're going to have to use what we know about simplifying radicals to get the root 3 out of the denominator. So we're going to rationalize the denominator by multiplying it by itself. And when we do that, we get root 3 over 3 as our final answer. All right, let's do the same thing with the tangent of 60 degrees. So going in, tangent of 60 degrees is going to be the ratio of the opposite side to the hypotenuse. So the opposite side was here, root 3a, and the adjacent side is here, a, and then we're going to simplify, and we get the square root of 3, or the square root of 3 over 1 if you want. So what we'll notice is that tangent ratios for given angles are known values, right? So in other words, the tangent of 30 degrees is always the square root of 3, no matter what. So if I'm working on a problem and I see that the ratio is the square root of 3 over 3, I can work this problem backward, right? And I can solve for the angle. So I can not only solve for unknown sides, I can solve for unknown angles. So let's take a look at an example, example 2a. So here's my 61 degree angle, and I've got the opposite side and I've got the adjacent side. So I'm going to write this as the tangent, or ratio of the opposite to the adjacent, of 61 degrees equals 22 over x. Now how can I solve this? Well, remember, this guy right here, the tangent of an angle, is a known constant value that I can look up. So I'm going to grab my calculator and I'm going to look up what is the tangent of 61 degrees. Okay, so I grabbed my calculator and I hit tangent 61 equals, and my calculator returned 3.743. So this is a proportion, right? Remember how we solve proportions? We're going to cross multiply and solve. When I cross multiply and solve this, I get x equals 5.877, and I'm going to round that to 88. All right, let's take a look at the next one. Okay, here's my angle right here. I notice that I have the opposite side and the adjacent side. So this is a tangent problem. So I'm going to write an equation. The tangent, or ratio of the opposite to the adjacent side, of 25 degrees equals 12 over x. This, remember, is something I'm going to look up in my calculator. Let's do that now. Right, we got to go back really quickly for just a minute. You were probably wondering where I got 3.743 from, because I'm sure your calculator did not give you the tangent of 61. So you should have gotten for the tangent of 61 1.8. All right, let's fix that. So now for a final answer on this problem, you should be getting 12.2, much better. All right, 12.2. All right, so back to example 2b. Let's look up the tangent of 25 degrees. We're going to get 0.4663. And again, this is a proportion. So we're going to cross multiply and solve for x. Okay, and then you'll find that x is equal to 25.73. So we're using known ratios of angles to solve for unknown values in triangles. Now, this isn't really that useful unless you apply it to something really useful, like a real world problem, right? Or where we do indirect measuring, like how can you measure a really tall tree or measure across a lake? And in order to apply trigonometry to these types of problems, we need to pick up a little bit more vocabulary. So the angle that an upward line of sight makes with the horizon is called an angle of elevation. Right, so we were doing some problems before we were talking about shadows, right? So like we were talking about, here's the sun is up in the sky, and the sun is shining down on the object, right? And then creating some kind of shadow over here, right? This angle that we measure with the ground is called the angle of elevation. So think about it this way. The angle of elevation is the angle in which you have to look up to the object. In other words, elevate, look up, okay? So let's take a look at our first real-world application. The angle of elevation from a person standing 250 feet from an office building is 25 degrees. Right, here's my angle of elevation. I'm looking up to the top of the building at 25 degrees. The person is standing 250 feet from the base of the building, and I'm trying to figure out how tall the building is. So what I notice in this problem is that here's my angle, 25 degrees, and relative to my angle, I have the adjacent side, and I would like to know the opposite side. So because I'm working with the opposite and the adjacent, that makes this a tangent problem. So let's write our equation. The tangent, or ratio of opposite to adjacent, of 25 degrees is, and then let's put in the opposite, x, and the adjacent, 250. All right, here we go. This guy right here, tangent 25 degrees. Remember, we looked that up on our calculator. Tangent, 25 degrees. This is a known value. So we replace this guy with 0.4663. And then we turn the rest of this problem into a proportion. Cross multiply and solve. So you should get that x is equal to 116.5, we'll round this to the nearest hundredth, eighth. And then because it says find the height of the building, instead of putting x equals, I'm going to put that the building height equals 116.6 feet, and I'm going to include units. All right, so that's how we use the tangent and the tangent ratio to solve for unknown values in triangles and then apply the idea of a triangle to a real-world situation. All right, let's try this one. A person is standing 30 feet from a flagpole. Let's draw a diagram. Okay, so this 30 feet from the flagpole. Here's the flagpole. And they're looking up to the top of the flagpole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground. Now what this means is that this is the person's eyeball. So there's an extra 5 feet right here that I'm not accounting for. That's a part of the flagpole. So when I solve in my triangle, because this is my triangle right here, I will be solving for this part of the flagpole, and then I will need to add the additional 5 feet on the bottom. So let's not forget to add that on at the bottom. Okay, so let's set this up. We have the adjacent side, and we are solving for the opposite side. So again, that's a tangent problem. we will replace tangent 35 with a known value from our calculator. So this is 0.700 equals x over 30, and solve this as a proportion. So we find that x equals 21. Now remember, that's not the height of the flagpole, that's only the distance that we just measured from here to here. So that means that the flagpole is actually this 21 feet plus 5 feet, so it's actually 26 feet. All right, next. So in addition to the tangent ratio, which compares the adjacent and the opposite side, we also have two other ratios called the sine and the cosine ratio. The sine is the opposite side compared to the hypotenuse, and the cosine is the adjacent side compared to the hypotenuse. So at this point, sometimes people talk about SOHCAHTOA. SOHCAHTOA. If you've ever heard of it before, it's just a shortcut way of remembering that S, the sine, is the opposite over the hypotenuse. C, for cosine, is the adjacent divided by the hypotenuse. And T, for tangent, is the opposite over the adjacent. It's only meant to be a way of remembering, like a mnemonic device of remembering what are the three ratios. So let's take a look at a couple of examples. Let's find the sine of angle A in this picture. So same as before, go to angle A, here's angle A. Find the sine. We're going to go opposite over hypotenuse. 15 over 39, and then of course we need to reduce this. All right, let's find the cosine of angle B. So here's angle B. So for cosine, we're going to go adjacent over hypotenuse. So the cosine is going to be 15 over 39, and again, we're going to reduce. Okay. All right, go ahead and pause the video, try parts C and, oh, looks like this guy's a D. Try parts C and D on your own, and then resume the video and check your work. Okay, you should have found that C was 12 over 13 and D was also 12 over 13. So you may have noticed that in the problem we just worked on, some of the answers were the same. And that's because these guys are called co-functions. Co-function. The co in co-function is actually short for the word complement. Okay, the complement function. And not the kind of complement like, oh, you have really nice hair. But this kind of complement, right? Kind of complement where if this is 40 degrees and these two guys have to add up to 90, that this would be 50 degrees and these two angles would be complements. So the sine and the cosine are actually the sine and the complement sign. And the rule for the sine and the complement sign is that they're the same if the angles are complements. If the angles are complements. So it sounds a little tricky, right? But it's not. So imagine you had a triangle that had a 5-degree angle in it right here, right? And you wanted to find the sine of this 5-degree angle. What this is saying is that the complement of 5 degrees, right, which would be 85 degrees, that would be the same as if you took the cosine of 85 degrees. So in other words, if these guys are complement angles, then these will be complement functions. Sine and complement sine. That's what cosine stands for. All right, let's do it again. Imagine we had a triangle. It had a 60-degree angle over here, and that would make this a 30-degree angle over here. So if I had a cosine of 60 degrees, that would have to be equal to a sine of the complement. So that would be a 30-degree angle, right? So these guys are complements, and these guys are complements. All right, we can use the sine and cosine ratio to solve for problems just like we can for the tangent. So finding the sine of 30 degrees, we're going to go opposite over hypotenuse. So from here, 30 degrees, opposite over hypotenuse. That's going to be a over 2a, and that will simplify to 1/2. You do the same thing with the cosine. Adjacent over hypotenuse. So looking at my picture, starting with a 60-degree angle, right here, I'm going to go adjacent. Oops, there's adjacent. I'm going to go adjacent over hypotenuse. Oh, I'm coming from the wrong angle. Let's try that one more time. Cosine of 60 degrees. Adjacent over hypotenuse. I'm going to get root 3 times a over 2a, and I'm going to simplify that, and I'm going to get the square root of 3 divided by 2. All right, write some equations using the sine and cosine to solve for x and y. So starting with my angle, 26 degrees, I've got opposite and hypotenuse. So I can write a sine equation. Remember, we're going to look this guy up on our calculator. Go ahead and do it now. Sine of 26 degrees. Okay, so you should get 0.438. Cross multiply this proportion and solve. You should get x equals 6.13. All right, we still have to solve for y. How should we do it? Should we use the Pythagorean theorem? No, we'll just use, this time, the fact that we have the adjacent side and the hypotenuse. In other words, now we can use a cosine. The cosine of 26 degrees should be equal to the adjacent side y over the hypotenuse 14. Let's look this guy up. Let's find the cosine of 26 degrees. All right, here we go. The cosine of 26 degrees. Turn this into a proportion, cross multiply and solve. We're going to get y equals 12.58. All right, take a second to pause the video and try to do example B on your own, and then check your work in just a minute. All right, so if you've checked your work, you should have found that on part B, x is 42.3 and y is 43.42. Now you may be noticing I'm rounding to different amounts. Hopefully you'll have clear instructions when you do your homework if you're supposed to round to like tenths or hundredths place. But if you don't have any instructions, you should round at least to the tenths place for your final answer. So, last couple of problems we're going to look at here go back to how do we apply this to the real world. So we talked about angle of elevation before, right? And now we're going to add to that the angle of depression. So depression generally means down, right? So how much do you have to look down? So if you were flying an airplane right here, right? The question is, how much would you have to look down? Normally, hopefully, pilots look straight ahead. How much would you have to look down to see something on the ground? That's the angle of depression. Okay, and the good news about the angle of elevation and the angle of depression is that they are alternate interior angles, which means they're always equal to each other. So if you're not sure where to put the angle of depression or elevation, you can put it in either one of those spots. All right, let's take a look at example 4. You're skiing downhill with an altitude of 800 feet, right? So that's this guy right here. The angle of depression is 15. Now, here's where you have to be really careful. A lot of people will put that right here because they think that they're working with this triangle. So obviously you have to put the 15 degrees inside the triangle. But remember, the skier is looking straight ahead And the angle of depression is the angle at which the skier is looking down, which means really the 15 degrees goes right here. So, do you have to put it there? No, you could have also put it down here because those are alternate interior angles. So now we can set up an equation, right? Here's my angle, 15 degrees. I've got the opposite side and I'm solving for the hypotenuse. So that's a sine. The sine of 15 degrees is 800 over x. So I get 0.2588 equals 800 over x. Turn this into a proportion. And solve for x. And I'm actually going to round this to the nearest foot because it asks me to.